Hello friend, welcome to the Java Puzzle. In today's video, we will explore the fascinating world of change data capture and the powerful tool called Debezium. But first, let's understand what change data capture is and why its crucial role in today's data-driven world. What is change data capture? It is a technique used to identify and capture changes made to data in a database. Instead of treating a database as a static repository, CDC allows us to track and capture any modification to the data, such as insertion, updation, or deletion. Why is CDC important? CDC play a critical role in several scenarios, just like real-time analytics. It enables real-time analysis of data changes for immediate insights. Data warehousing. It facilitates the integration of data into data warehouse for reporting and analytics. Synchronization. It keeps different database or system in sync by propagating changes across them. Data integration. It supports efficient data integration between different applications and systems. What challenges we will face if we will not use CDC? Without implementing CDC, organizations face challenges just like as a latency, in which the application delay in accessing and utilizing the latest data. Complex ETL processes, where there will be lengthy and complex extract, transform, and load process. Data inconsistency. It can be possibility of data inconsistency between different systems. Missed insight, in which there would be some difficulties in capturing real-time insights due to outdated data. So what is Debezium? Now that we understand the importance of CDC, so let's talk about Debezium. Debezium is an open source platform for change data capture, and it designed to capture and stream changes in real time from database log to various destinations like Kafka. Why use Debezium? Let's explore some compelling reason to use Debezium. First one is real-time data streaming. So Debezium capture changes as they happen, providing real-time access to your database agnostic. It supports various databases like Postgresql, MySQL, MongoDB, and many more. Low latency. It minimizes the latency between changes occurring in a database and their availability for process. Event-driven architecture. It enables an event-driven architecture by streaming changes to message broker like Kafka, RabbitMQ, and any other. No impact on source system. So Debezium capture changes from the database log and ensuring no impact on performance of source system. And we will set up Debezium to capture changes from a PostgreSQL database and stream them. So we are going to implement a master-slave example where master will be store some data in PostgreSQL, and that PostgreSQL call the Debezium connector, and that Debezium connector will store the same data in a MySQL, or we can say slave data, and we will check our changes in the slave Spring Boot application. So this will be the implementation of this project. So let's firstly create a backbone of this project, and then we will go to the Debezium. So firstly, I open the Spring Initializer, and I will just quickly change the name. So it would be Spring Boot Debezium master slave example, and let me change it into a artifact, and the group ID would be com.youtube.javapuzzle. Description would be master slave Spring Boot Debezium example, and the package would be the com.youtube.javapuzzle. That is fine. So let's add some dependencies here. Firstly, JPA, web, Lombok, and for now that is only the way required. So just click on the generate. So I quickly open my Spring Boot application in IntelliJ. You can use Eclipse or any other favorite IDE. So for now I don't require anything here, so I'll delete this because this would be a multi-module project. So only the pom.xml is here, nothing much is here. So now let me add the Docker Compose file, and here in this Docker Compose file, define a multiple container environment for setting up a data integration pipeline using our Apache Kafka, Debezium, PostgreSQL, then PGAdmin, Zookeeper, and Confluent schema registry. So let's break down the file section by this. Okay, so first one is the service, and inside the service we have a PostgreSQL service, and in this PostgreSQL service, this is the official Debezium Docker image for PostgreSQL version 13. Then we have a map which will be map the container PostgreSQL port 5432 to the host port 5432. Then we have Postgres username, password, and the DB name. Then we have a PGAdmin service, which is the official Docker image for PGAdmin 4, and a web-based PostgreSQL administration tool. And the port is running over the 5051, and this is the default email and default password for the PGAdmin. Then we will talk about this Zookeeper. So this Zookeeper is this 5.53 is the official Docker image for the Apache Zookeeper, and it set up the Zookeeper client port over the 2181. Then we have a Kafka service over this 5.53 same image, which is a Zookeeper. So same image we will take here, and this is also official Docker image for the Apache Kafka. You can get from there also. And this Kafka Zookeeper connect, it specify the Zookeeper connection for the Kafka, and this advertise listener, it will configure the advertised listener for the Kafka. And then we have a Kafka offset topic replication factor. It set the replication factor for the Kafka offset topic, and the port is running over the 9092 for the Kafka. Then we have a Debezium service, and the official Docker image is 1.4, and it's depend over the Kafka. So it ensure that Debezium service start after the Kafka. So it should be mandatory, like Kafka should be run before Debezium. So it's depend over the Kafka. Then if we talk about the other environment here, so it configure various property for Debezium, including Kafka bootstrap server, then group ID, storage topic, and converter set, and the port is running over the 808. Then at the last we have a schema registry, which is 5.53, the same version which we are using for the Kafka and Zookeeper. So same version we will use here, and here in the environment it configure the schema registry properties such as Kafka, Kafka store, connection URL, host name, and the list, and the port is mapped over the 8081, and it's depend over the Zookeeper and Kafka. So it ensures that the schema registry service start after the Zookeeper and Kafka. So this Docker Compose file set up a comprehensive environment for data streaming, including the tool for PostgreSQL, Kafka, Debezium, and schema registry. So making it suitable for building and testing data integration workflow. So let's check out our PGAdmin first. So let me run this. So for me, I already have an image in my system, so it won't take much time, but for you it won't take some time, but bear with the time. Okay, so let's check here. All the services up and green. Okay, so we are good to go with our browser. Okay, so firstly let me open the PGAdmin so we can set up our DB first. Okay, so here localhost 5051 is our PGAdmin. Then let me copy the default email and password which we given in a property file, the YAML file, and just log in it. Incorrect username password. Let me check again, maybe some space admin. Move this and hit again. So it's successfully logged in. Now let me, so server is not connected yet, so let me register one server. So Java puzzle connection would be the host name. So host name which we provided here, it's a Postgres. So let me add the Postgres. 5432 is fine. Maintenance DB name is Debezium master. So let me provide the Debezium master and Docker, and password is also. Let's save it. Now our server is registered. Now let me go in the database, Debezium master, schema. So for now we don't have any table here. So here our Debezium connector is also up and running over the 8083 port. So let me first add one more YAML for you. So this is a Debezium JSON, and here firstly we will give our connector Okay, we have to register our connector. Okay, so here we will provide the name, it can be anything. Okay, then we have a config details of this connector. So inside this config you can see that there is a connector.class, and it represent that we are registering a connector for the Postgres connector. Okay, then we have a plugin name which is a PG output, and then we have to provide the host name which we provided in the Docker. So in here you will see we have a host name as a Postgres, then port number 5432, username is Docker, password is Docker, DB name is Debezium master, server name is also Postgres, and here in a table include list we have to provide our whatever the table name where we want to, or schema name where we want to implement our CDC. Okay, so here we add some schema like customer and employee. So let me first create one customer table, and then we will register this connector. So here let me open this, and so let me copy this customer, create, and here just query tool, insert it. So let me create first a customer, then we have to alter this table where we will add the replica identity full. Okay, so we will give the replica identity full for this table, and just done. Okay, so now let me refresh it, and you can see there is a customer. Okay, now the next thing, we have to register our connector, and this connector is running over the 8083. You will see here our connector, Debezium connector, is running over the 808. So I will open it, and let me close this. If I will check the get, and if I will send, you can see there is a blank. So currently we don't have any connector added. So if I will hit it, make it post. Now let's hit here. Now you can see it's return the same, but task is blank and type is source. If I will click on the get and see is present here, so we can see it's returning the connector name. So as we added the Debezium master connector, so it is returning here. That's mean our connector is registered. Now let's go to the our DB, and before inserting any details, let me open terminal here, try it, and let me open my CMD here, and I will run this Docker. So in this command, it will run the, firstly it will create a image for Kafka cat. Okay, currently in a Docker we don't have any Kafka cat image, so it will create a Kafka cat image, and it will run over this network, and it will check every time when we insert, delete, or any changes will happen over this table, customer table. Okay, so the name, this name should be a network name. Okay, and then underscore default we can give. So let me run this command in my CMD. Okay, so I'll hit it. So sometime this error will come. Okay, broker leader not available. No issue, don't panic, just rerun this. Okay, now you will see this message is showing reach end of the topic this at offset 0. So we are good, and let me insert some value. So let me insert, okay, the customer name, our favorite name is Java Puzzle, city is Stavanger, and Norway is fine. So let me insert in the DB. So insert it, query returned successfully. Let me go here, and Kafka cat is not responded. Let me rerun this. Now you can see this Java Puzzle, string Stavanger, and country is Norway. Let me insert some other values also. Let's suppose Savan Kumar, city Faridabad, country India. Okay, let's insert it and see. So now you will see, let me check the other value is still there. No, let me enter. Here you can see the Savan Kumar is came here. Savan Kumar 4 is coming. Oh, I was okay. So we inserted here. Now let me update this value. Let me first reload it and just check everything is inserted or not. So select star from public dot customer. So I will hit it. So 7,4 is coming. Okay. Now let me update and see what will come here. So update copy condition and just put here. So we just have to change only the customer name, nothing else, right? So it should be Savan Kumar, not again, and customer ID equal to 2. Okay, so if I will hit it, it will update it, and here you can see it will update here. So here you can see before it was in previously you will see before is coming as a null and after this data is coming, but when we will update it, so before these are the details was in the table 7,4, and after you will see there is a 7 Kumar with the change, right? Understand? Now let me delete this. Okay, delete public dot customer where customer id 2. Okay, so let me run this. Oh, delete from, right? Inserted, it's returned successfully. Now here you will see these details. Before is this, okay, and after is showing null, right? Because the record is deleted. So that means, so what you observe here, when we will firstly insert, then before was null and after was some value. When we will update it, then our before was the old value and after would come with the new value. And when we are deleting it, then we have a before with a previous value and after with a null because data is record is deleted. So we see all the three main query of the table and how this Debezium is work. Okay, so in next video we will see how we are going to integrate this Debezium using the Spring Boot, and then we will build our master slave application. So for now, thank you for this support, and if you think video is helpful for you, then share with your friend and stay tuned for the next video. Thank you.